Hello, we're gonna discuss today about the important topic of trigonometric identities. It is a very well-known topic in class 9, 10th, 11th and 12th. Basic foundation of trigonometric identities. We start with sine theta, cos theta, tan theta. Now in class 10th, we are all aware the values of sine theta, cos theta and tan theta are given by the formula perpendicular upon hypotenuse. So in triangle ABC, the side which contains the angle is considered as base, and the side opposite to the angle is known as perpendicular, and the side facing the right angle is hypotenuse. This is very basic of trigonometry, as we have learnt in class 10th that expression sine theta is given by perpendicular upon hypotenuse, that is AB upon BC. AB upon BC. Cos theta is given by the expression base upon hypotenuse, that is AC, base upon hypotenuse, and tan theta is given by perpendicular upon base, that is AB upon AC. And remaining values cosec theta, sec theta and cot theta are just reverse of all these values. So this portion of trigonometry we have learned in class 10th, and we have learned to find out the values of sine theta, cos theta, tan theta. When we move to class 11th, in class 11th mathematics, we are exposed to the periodicity of the functions sine theta, cos theta, tan theta. So to understand what it means, first we must understand what is a periodic function. Sine theta is a periodic function as when we start moving along a circle, the angle subtended by the point is theta. It goes on increasing up to 90 degree as the length of perpendicular is increasing from 0 to maximum, and then from 90 to 180 degree the length of this perpendicular start decreasing. So the value of sine theta increases from 0 to 1 and then decreases from 1 to 0. Again it moves to -1 to 0 and finally comes back to 0. So we see that the values for all the angles are lying between -1 and +1. We see that value of sine theta repeats after an interval of 360 degree, that is 2 pi. So this is known as a periodic function, and the period of this function is equal to total angle of the circle, that is 360 degree or 2 pi. I hope this is clear so far. Now when we say the angle is negative, what does it mean? If the angle is subtended in anti-clockwise direction, in anti-clockwise direction the angle is taken as positive, and when we move in clockwise direction the angle is taken as negative. It's quite simple. If we are moving anti-clockwise the angle would be positive, and if we are moving anti-clockwise the angle would be negative. So when we come back to triangle APO, which is a right angle triangle inside a circle, and the circle has a radius of 1 unit. That is, it's a unit circle. And we write down the formula for sine theta. Sine theta is simply given by AP upon OP. AP is perpendicular, OP is hypotenuse. And if we take the coordinate of this point on the Cartesian plane to be x and y, this distance AP is y. So we have written AP equals to y upon OP is 1. This is hypotenuse, which is taken as 1 because we have taken a unit circle. So the value of sine theta is equal to y. It's fair enough. Simple calculation. But when we are moving in clockwise direction, we are moving in this direction, then this angle is taken to be negative, that is minus theta. So when we take sine minus theta, so the triangle involved is OP dash A. In this triangle OP dash A, we take sine minus theta equals to perpendicular is AP dash. This is AP dash upon OP dash. Again AP dash is minus y, as this is negative y direction. This is negative y direction. Direction is taken along the negative side of y axis, so this is taken as minus y. So minus y, and the value of sine theta is minus y. So this comes the minus, and this y is again equal to sine theta. So sine minus theta is equals to minus sine theta. Okay, we try the same concept with cos minus theta. While calculating cos minus theta, we need to take base upon hypotenuse. So what is base? That is OA, and hypotenuse, that is OP dash. So the value of OA is again x taken along the positive direction of x-axis, which is positive. So x upon 1, and x upon 1 is the value of cos theta. If we take the upper side triangle, again cos theta is x. So we have taken x equals to cos theta and deduce the formula cos minus theta equals to cos theta. Tan minus theta, tan theta is simply the ratio of sine theta and cos theta. So tan minus theta is sine minus theta upon cos minus theta. Now that we have found that sine minus theta is minus sine theta, so we have taken the sine out, that is minus sine theta, and cos minus theta is cos theta. So minus sine theta upon cos theta again comes to tan theta is minus tan theta. Let's understand the effect of this on the respective values. We have learned that the values of sine 0 degree, 30 degree, 45 degree, 60 degree, 90 degree are given by sine 0 is 0, then 1 upon 2, 1 by root 2, root 3 upon 2, and 1. Cos theta is started from backward, that is cos 0 1, cos 60 is equals to root 3 upon 2, cos 45 is 1 upon 2, cos 30 is 1 by 2, and cos 0 is 0. Tan theta is simply the ratio of these two values. What important feature we observe over here? The value of sine theta is increasing as we are moving from 0 to 90. Let's come back to the circle. We are moving from 0 degree to 90 degree, and the values are increasing. So while drawing a graph of these values on the Cartesian plane, this is 0 degree. As we move on, sine 0 keep on increasing. It reaches the maximum value at 90 degree and comes back to 0 when we move further. This graph is a periodic function and represents the value of sine theta. So this is the graph of sine theta. Again, if we draw the graph of cos theta is simply maximum at 0 degree, that is 1, and keep on decreasing as we move further. So the graph of cos theta is plotted like this for the different values of the angle taken over here. Interesting graph of tan theta. Tan theta can also be drawn over here. We see that the values of tan theta is tan 0 is 0, and as we move on further we see that the values are increasing. It reaches to the maximum at 45 degree, then further increases and goes up to infinity. So the graph is somewhat like this. This is a graph of tan theta. So to understand these graphs, we must remember that the periodicity of these trigonometric ratios, and we must take note that sin theta repeat its value at an interval of 2 pi. So we say that sin 2n pi plus theta is equals to sin theta cos 2n pi plus theta is cos theta. But what about tan? The tan theta is periodic with an interval of pi. N pi plus theta equals to tan theta. These are important values to be kept in mind while solving the question of trigonometrical identities. Further, we will solve some question from NCERT on this topic.